Hello, Hammersmith, and hello to everyone online. My name's David Greenwood, and it's the end of the world as we know it. Which brings me nicely on to my presentation. Over the next 20 minutes or so, I'm going to take you through my journey with AI and large language models over the last 12 months. And more specifically, large language models and AI when it comes to a CTI context. Now, my presentation is going to be a bit different to some of the ones you've seen earlier today in that it's a bit more process-driven. I'm not going to come and show you a lot of previous research, but I'm going to show you how AI can potentially help you in performing the research. So, I, like 99% of LinkedIn, consider myself a pseudo-AI expert. So I think you'll come away today with the ability to start thinking about building your own large language model with CTI data. But keep in mind, I'm no expert either. So everything you see here has been in the course of 12 months of learning. And I work for a company, as Sophia introduced me there, that builds a threat intelligence platform. And it's only over the last few months or so, 6, 7, 8 months, that I've started to look at building AI features into the products we're building. And I also consider myself a pseudo-expert in philosophy. I am also very arrogant. And if we distill AI down, AI is really just the simulation of human intelligence processes. And these processes are essentially based on previous known information points. And if we go back in time, one of the earliest records we know of humans storing data is a tally stick. And some would argue this is the first example of counting prime numbers. But we start to develop very quickly over time. We start to develop languages and symbols to create more descriptive ways of describing what we're talking about. And we start to collect that information in centralized knowledge stores, and we start to see the first, what we know as today, libraries. And as we move through time and we get closer to the present day, we get the age of computing, where we start to store and retrieve data at a much larger scale, which brings us onto the age we're more familiar with today, the internet. And I don't need to explain the internet to you guys. It's cat videos, memes, and porn. Which brings us to the so-called AI revolution. Now, AI is nothing new. The field of mathematics and probabilities has been around for centuries. But it's only over the last few years with the advancements of technology that we've been able to start to really utilize large-scale research. And that's why we're starting to see the advent of these AI companies now, and it becoming into the consumer mainstream. And ChatGPT is probably the largest and most well-known, even though they're going through a bit of dramas at the moment, which has nicely coincided with my presentation, unfortunately. Now, I'm sure like me, a year ago, you went through the 3 stages of discovering ChatGPT. The first was, this thing's going to take my job. I'm going to become destitute. What am I going to do with myself? In fact, there's a stage before that between you and me, and that's actually pronouncing ChatGPT correctly. Half of my family still call it ChatGTP, but that's another story. You then get onto the phase of, I'm smarter than you, you're just a machine, which is very quickly followed by the third stage, which is that, oh, wait, this thing is pretty good. I'm going to use it for everything. And when I speak to people about AI in a professional context, as I'm doing today, a lot of the pushback I get is through the fear of the unknown, right? This idea of job security mainly. But I'd argue in the field of CTI, we're probably fairly safe in terms of job security, or at least one of the safer industries. And that's because at which the pace this industry moves. We're fighting attackers who are quickly evolving, right? The attack vectors evolve, the malware they're using evolves, the machines that are distributing that malware are cycled through fairly quickly. So a model trained on data, even from the middle of this year, is somewhat out of date for many of the research cases many of you in the room will be performing. The open models on the internet just don't have the live battlefield data yet. And jumping back into my time machine, AI and CTI is nothing new. We've had tools like MITRE-TRAM, which stands for Threat, Report, Actor Mapping, for a long time now. So for those of you who don't know what this is, it'll take a PDF, it'll analyze the contents of that PDF, it'll break out the sentences and the paragraphs, and then using natural language processing, what it will try to do using the models in the back end is associate attack techniques with those paragraphs and sentences. But it's limited to attack techniques. And in my research and in my world, that's great. It's a great start, but it's not enough. I want to go much further than just attack. So for last year, I've been developing this presentation, and it's changed forms quite a few times. The first version of this presentation was really looking at how do I make life easier for a junior analyst. And I think I've spoken to a few junior analysts in the room today. The idea being that a senior analyst knows a lot, but when you're first getting started on the job, there's lots to consider. Knowledge bases, definitions, classifications, all types of things. And I wanted to do away with that. I just wanted to let the analyst go write a report and have it disseminated easily between their colleagues. But I quickly realized the junior analyst would need a structured way of disseminating that intel. I needed a standard way for downstream people, or what I really mean, downstream machines that those people use, to understand the intelligence that those junior analysts were writing. How many people in the room are familiar with sticks? A few, maybe a tenth, rough calculation. Now, when I was looking for a structured way to start disseminating this intelligence, I'll give you a full disclosure. I work for a company that uses sticks as an underlying data model. I do a lot of training on sticks with said company. So it's an easy decision for me to make. But for those unfamiliar with sticks, firstly, where have you been? But secondly, sticks is ultimately a predefined set of objects to describe common intelligence concepts, right? So we have campaign objects, indicator objects, malware objects. You can see some of them listed on the screen up there. And using these range of objects, you can start to tell stories. An APT group using an attack pattern in a campaign. All of those are sticks objects, and they each contain specific details of the story. The benefit being, if a junior analyst shares those sticks objects, the downstream machine, the tip, the SIM, the SAW, will understand that intelligence and be able to utilize it off the bat. So developing this into a POC for those junior analysts. On the left side, you see a prompt describing a scenario inputted by the junior analyst. So in this case, it's some infrastructure, and that infrastructure has got a vulnerability. So what I've asked ChatGPT to do is take that scenario and generate what is called a sticks bundle. Without going too techie here, which I do have a habit of doing, a sticks bundle is just a collection of those sticks objects that tell that story. The screenshot on the right is a rendering of that sticks bundle. So in this case, that rendering software is a downstream solution. That might be my tip, it might be my SAW, it might be whatever. In this case, it's just a viewer to look at the intelligence and look at it graphed out. The too long didn't read version, or didn't watch, or didn't listen, I'm not really sure how to describe it, of that presentation was ChatGPT is pretty good at creating CTI reports. And it's continued to get better. So at the start of the year, OpenAI introduced a really cool feature. You could upload documents or images, and it would be able to natively understand what was inside of those images. And that was really good for someone like me who likes to take a lot of notes. But it's also good for everyone in this industry. And this is a killer feature. Here's why. So again, developing this out into a proof of concept. Here's an image from a report on the left of a malware string called Quackbot. So I've asked GPT, like before, to convert what it sees into structured intelligence, into a sticks bundle. Not only does it detect the IOCs when I put it in here, it also detects contextual information that's not in the image, that Quackbot is in fact a malware. Neat, right? And this has far-reaching implications. A large part of threat research is researching research. Emails, PDFs, threat feeds, blogs, Slack messages, all kinds of things. Many of us rely on these things day to day in our operational work. And as we've seen, ChatGPT is really good at turning these things into structured reports. Showing another example, here's a bit of text from a Unit 42 report. Feeding it into ChatGPT again, we get that structured file. Simple at this point, easy stuff. But now I started to run into problems, because these reports can be very long, right? A PDF report can be pages and pages and pages. And this is where we run into problems with ChatGPT, this idea of tokens. For those not familiar, tokens are a count of the size, roughly, of what's being put in and what you're getting out, so the prompt and the response. ChatGPT used to have a limit of 4,000 tokens. Recently, OpenAI have brought in new models, specifically GPT-4, that can handle 128,000 tokens. Now, to put that into context, that's about 100,000 words or 300 pages. Now, I don't know about you, but that covers most of the Intel reports I read, except for the ones that have been written by a threat analyst who has an English literature degree. Now, I have a confession to make. I've shown you the ChatGPT UI, and I wasn't actually using the UI, although everything I've done is totally possible in the UI. I was using the API. I quickly lost the will to live copying things between the UI of ChatGPT and the viewing software I was using. But the point of this is, this research or this processing can now be done at scale with relative ease, no matter how large the input or the output. And this is superb, because ChatGPT is really good at also working beyond the IOC. I mean, who works with just IOCs these days? Well, I'm not going to name any companies that I work with that do, but there's some out still out there. But at this point, you get into very verbose outputs, right, that are not often structured in their very nature. So we can do some malware analysis in ChatGPT. We can feed in the code and say, hey, what's going on here, right? Speculate on the purposes of what it's trying to do. Identify where the malicious activities are happening in the code. So of course, I turn to ChatGPT again. I say, hey, structure this analysis so I can send it to someone. It creates a sticks malware object, and attached to that is a malware analysis object. What I think is really cool about this is you can see the raw sticks object right in the far corner on the left there, and ChatGPT is the analyst, which I think is pretty cute. But now we go down another level, right? Because you now have the SOC teams who are saying, this intel's great, you've written tons there, and it's amazing. But I just want to detect this stuff. I want to put it into my SIM, and I don't want to have to read all this stuff you've written. It's very useful. I just want to detect it. So we start to ask for different things. So now I take the same example, and I ask ChatGPT, hey, create some Splunk detection rules for Quackbot. And it creates 5. Now, I don't want to get into a discussion around the ethics or the morals when it comes to copyright with AI models. But if any of my old Splunk colleagues are watching, ChatGPT is stealing your data. I'll just leave that there. But going back to the malware for the moment, it's not perfect. And it's not perfect because the objects that are being spat out are not necessarily standardized. It's not useful if every single researcher creates a Quackbot sticks object. The analysis that's attached to that object is unique to the researcher, but they're describing the same thing. So you quickly get into problems of deduplication if everyone's creating these things. And this is a problem well solved in our industry. There are central knowledge bases that exist that are stores of this type of data. The one most of you in this room are probably most familiar with is attack, right? But as you can see, ChatGPT has no idea, or had no idea, about the attack sticks data. An attack does indeed have a sticks object for Quackbot, as I show on the screen up there. And this is where the two biggest limitations of ChatGPT come in my opinion. Where it gets the data from, and when it got that data. So now the AI expert says, great, I'm going to go away and train my own model. I'm going to change the world. And after a quick bit of Googling, you come across this. Now, I don't know any of those people in that photo, but I wanted to show you that picture because you don't get a lot of money, you don't get a lot of kit for your money. And it's a lot of money, and you probably don't need to train a model. There's this concept of retrieval augmented generation. That is feeding something you know into a model and asking it to be retrieved later. So in this case, I feed in the attack sticks object for Quackbot, and then in future responses, it's able to return that to me. So now we get that standardization. But I hear you ask, well, am I going to have to feed in the whole attack data set every time I want to work with ChatGPT? It's a tough answer, but in short, yes. But it might not be as difficult as you think. There are solutions to deal with retrieval augmented generation. LangChain is essentially recipes for chaining these things together, chaining the prompts together to actually feed in that information. But doing this with open SaaS-based LLMs is expensive because each of those prompts you feed in, you're being charged by the token. So the more times you have to feed this in, and if you have to feed in those prompts every time, you're going to be charged every single one of those tokens each time you want to work with it, which is just not right for most. So sometimes you do need to fine-tune the model. And this isn't as difficult a process as you want. Notice I said fine-tune, not necessarily train. And you can train a model quite easily if you know the information that you're feeding into it. So in the case of attack, attack is a standardized data set. It's open to the world. So I can train ChatGPT or train an AI by acting as both the user and the answerer, so the AI. So I feed in the question, what is the attack sticks object for Quackbot, but I also feed in the answer, here is the attack sticks object for Quackbot. And you can do that programmatically fairly easily. But there's still another big limitation to ChatGPT, and perhaps the biggest when it comes to any AI, any SaaS AI for that matter. It's data security. No one wants to be this headline. And many of you will have already dismissed this presentation just by the nature of the companies you work for. Many of the clients I work with ban even uttering the words ChatGPT in their offices. I can't put my data into ChatGPT, they exclaim. The content is sensitive, and they're right. The licensing, my Intel vendor, who I'm buying ThreatIntel from, would not be happy if I publish all their data into a publicly available model. Also true. And it's a black box. I don't know what's going on inside of there, and I also don't know that what's coming out is accurate and correct. Also true. The good news is there are lots of open source models that you can build with and interact with that are very similar to ChatGPT. So here's one called GPT. Frill has a very similar interface to ChatGPT. But the underlying models are pretty crap, if I'm honest. Excuse my French. So they do require some training. Now, I work for a threat intelligence company with a threat research team. We have a huge amount of intel. We continue to generate that intel. So we have a good data store to begin with. I have the knowledge to make a specialized CTI model. Which brings me to the second part of this presentation, which I unfortunately don't have time to talk about today. But using a base model like Meta's Llama, for example, it's surprisingly easy to train with CTI data. The biggest limiting factor is having the CTI data in a structured manner to start with. Now, assuming you have a threat intelligence platform or some data store of intelligence, it's very, very easy to take a base model and to start tuning it so it's very specialized in this world of CTI to return those answers we're looking for. So if you're interested in going a bit deeper or want to have a look at the second part of this presentation, I'm going to be around for the next day, and I'll be around tomorrow, so I'm happy to sit with you. If you want to grab me outside or drop me a message on LinkedIn, please do. We can meet up. But other than that, I've been David Greenwood. You've been a wonderful audience. Thank you very much.